Hi, everybody. Thank you for joining us today for Living on the Edge, Harnessing the Power of Data Beyond the Meter. I am joined today with Mike Phillips, the co-founder and CEO of Sense, and we have Tim Weidenbach, the Senior VP of Technologies for Landis+Gyr. As we know, the energy industry is transforming at a rapid pace with consumers and clean energy initiatives serving as catalysts for change. Exploring the world of data beyond the meter made possible by Revelo. And as the world's first and only grid sensing meter, Revelo and its application ecosystem support consumer-facing applications such as Sense, providing significant benefits of utilities and their customers. Before we get into questions, Tim and Mike, are you all having a great day so far?
Yes, indeed.
We are. Thanks, Joyce. Glad to be here.
So happy to have you. Just a quick thing for the audience members, if you would please drop your questions into the chat, we'll do our best to answer them throughout. With that, let's get started. So Tim, Landis+Gyr led the first wave of AMI technologies and are poised to lead the next wave of AMI or AMI 2.0. What does the future look like with AMI 2.0?
Joyce, I joined Landis+Gyr 15 years ago, and prior to that, I am an old distribution engineer. I spent the rest of my life at the utility, so I sort of walked into AMI seeing it with a different lens, and you'll hear that today. And it's changed the way the edge of the grid can be managed, and it's changed the way consumers can be served. But I came to Landis+Gyr. I did a lot of work in Texas, was involved with a lot of major deployments here in Texas, and wave one or AMI 1.0, whatever you want to call what happened starting around 15 years ago, there was a baseline for a more sustainable grid. The intention was that, and everybody needed to kind of they needed the same specifications. What are we trying to do? What are we targeting? And a baseline set of capabilities were set out that achieved a lot, but they were really driven more for operational benefits than anything else. Not a lot of discussion about what's the quality of power at the edge of the grid, but it's more around how do we change the operations of a utility's ability to read meters? How do we get the consumer engaged with some baseline demand response capabilities and just start to automate data from the edge? Wave two is significantly different because it opens up so many more possibilities based on just think about 15 years ago, what was in your pocket as far as a cell phone. I mean, we were just getting used to our lives changing from a cell phone, and technology changes from then until now are just as big in the smart meter world. So our ability to do things at the edge now has just advanced enormously to those big benefits I saw as an old distribution engineer, where I saw, wave one, what do we care about the voltage profiles? It wasn't a priority at that point, whereas I thought that would be hugely helpful. Now we have so much even more data capability to really understand not just what we're measuring, but the characteristics of that power quality. And you're going to hear a lot from Mike on how, I see that as a distribution engineer benefits, huge benefits to the consumer that you'll hear from Mike. In the fact that you're no longer just seeing bits of data, you're seeing real time what's happening to a consumer that he can use to manage his life. So huge advancements from the wave one to wave two and capabilities we're able to bring to market.
Awesome, thank you. Mike, do you have anything to add?
Yeah, just to pile on to what Tim said, I actually and most of the people here at Sense came from a very different direction. We come from the consumer-facing technology world, actually previously in telecom. So I was working on a couple different companies doing speech recognition or voice assistance on mobile phones. And we went through the transition that the telecom world went through, where it used to be a phone was just a phone. And if you wanted like a navigation system, you'd have to buy some new piece of hardware. And then the telecom infrastructure, in fact, the smartphone, completely transformed that industry. So we started Sense in 2013 with a view that the same could and should happen in the energy world. How do we take what we know from consumer-facing tech and apply it to making engaging consumer-facing applications? So when we started the company, we looked at existing AMI data in meters and said, is this good enough to build an application? We decided it wasn't. So we've been in market for some years now with our own behind-the-meter hardware, this little, I brought one here, a little orange box that goes inside the electrical panel, measures the power just like a meter does, but at really high resolution data, lots of edge computing, good networking. And we use that to build up this real-time engaging consumer application where we measure the power in a super detailed way that gives us ability to know what's on and off at any point in time, just based on the power signatures, and to provide a real-time consumer-facing experience around that. So that's where our background is. And you'll see as we talk here, the really exciting thing is we've now, and actually been working for some years now on this AMI 2.0 on Revelo, where everything I just described is running just as an application software on this new Revelo meter, working with Landis+Gyr folks. So again, it's very analogous to instead of buying separate hardware for a music player or navigation system, you just got all these things as applications on your phone. The same can happen on the energy infrastructure and on meters in particular.
That's really fascinating. And in fact, kind of like leads into the next question, which is, with all the advancements in metrology today, what does the future of metering look like with applications like Sense?
Yeah, maybe I'll start from the consumer side and let Tim weigh in on what this means for utilities. So, from the consumer side, our view is look, there's more and more desire for decarbonization, which we're all very focused on, requiring more and more renewables on the grid. We do need engaged consumers, both to be more efficient, obviously, but it's becoming really important, not just how much energy you use, but when you use it. So that really requires consumer engagement, because consumers have a lot of impact on what happens in their homes. Obviously, we'll be doing more and more automation over time, and we're doing that today. But no matter what, there's going to be need for consumer involvement in that. And again, our view is to involve consumers. It has to be broader than just energy, and it's got to be this real-time engaging experience. And that's only possible if you can do it with the kinds of technology that Landis+Gyr has brought to the new Revelo meter.
Yeah, Joyce, when Mike and I met years ago, we sort of came together at the same conclusion, because Mike was attacking a problem for the consumer that I saw as the same problem for the utility to solve right there at the edge of the grid at the meter, which was just at the premise level. So I looked at it as about how to provide best service for my customers. And the biggest change in the meter is granularity of data, number one. How much data are we actually able to look at in the meter? And secondly, how do we enable capability for more to happen at the meter level? Or it's not really about meters, it's just IoT devices that are at the edge of the grid. Just so happens everybody's got one on the side of their house. As a distribution engineer back at the Southern Company, I worked at Georgia Power most of my life. I spent a lot of time helping customers with quality issues that we were creating, but we couldn't explain why. And a lot of times things are so intermittent, it's very hard to diagnose what might be happening to cause power quality problem at a customer's house. Well, Mike was looking at appliance level data. It's the same data I would look at for this. He used a great word, and it's signatures, and we call it waveform processing. But essentially, instead of just measuring how much power you used or what your voltage was on average for the last 15 minutes, what does the quality look like of the signature of that power coming into your house? What did I have to solve for it with 20 years ago prior to this evolution? For all the distribution engineers, you can geek out on a term. Remember Dranitz meters, basically a big suitcase device that I would go hook up in a customer's home, leave it for a week, and come back, and I would look for a signature. I'd look for things that were characteristic of a certain kind of problem in the neighborhood, at a feeder level, or really down at the neighborhood level. That's capability is in every meter now. We're bringing that capability where a distribution engineer can triage a problem with data that's readily sitting in everyone's meter right now. And how do we make that available? That's really how we think it's evolved to the future of, if you add a platform for a partner like Mike to come in and then build inside the meter something of value for the utility, something really powerful. So that's how I see it changing the ability on the grid side, as well as what Mike's doing on the consumer side.
Thank you. You mentioned data, right? So let's talk about data, right? The Sense application really gives utilities and customers a unique opportunity to see into the home with granularity that you mentioned that identifies those unique signatures. So how exactly do you guys go about doing that with this application?
Yeah, so there's actually a number of things required to do all the stuff that Tim and I are just talking about. It does start with data. We need very high resolution waveform data. This is not even like 1 second interval data is not nearly good enough. We need to see the actual voltage and current waveforms going into a home in order to do things like detect that a incandescent light bulb just turned on because we see that the tungsten filament, as it heats up, the resistance goes up. So the first 30 milliseconds, there's a very specific exponential decay in the power signature. So it's all those kind of crazy details that we are using to figure out what's going on in the home. And as Tim mentions, you can use and look in the other direction to see what's happening in the grid. So that high resolution data is one key part. The next necessary part is edge computing, because you can't send all that data up to the network all the time. You have to have edge computing that lets you process everything locally in the meter or in the home. The next is you do need flexible networking. So in addition to the normal networking you might use for billing data, you need the ability, especially if you want an engaging consumer real-time application, you need low latency networking. So you need a way to do that, whether it's Wi-Fi or cellular or some other technology for low latency networking. And then one final piece that brings us all together is to have an application platform where this is now over-the-air updates of applications and data versus thinking of a meter as a fixed thing that never changes. We have to be able to update software on an ongoing basis. Tim, did I capture all the bits and pieces required?
You did, you did, Mike. And there's, and again, it's not that it's what Mike's doing inside the home, we're trying to do at a community level for the edge of the grid. So what's going on your street? But it's very similar. And how do we maximize that? First of all, and maybe someday we'll have completely open maximum bandwidth pipes. The 5G world will allow as much data flow as you want. But until that happens, we want to send the right data up to the cloud for doing enterprise level solutions for system problems the utility's dealing with. We want to do as much as possible locally, like Mike's doing in the home, so that you understand what's going on with your neighbors. And in a world where the grid needs to enable all the intrusion that it's going to happen with many microgrids and renewables coming in and out of the system, and if that reality is going to happen in the future, you're going to have this ability at the edge to manage locally, so disruption doesn't get to the point where if you're not part of that microgrid solution, your power's not at risk. So we feel like the same applications needed, and then just properly manage the data. We don't need to be streaming every bit of data back to the cloud, but we need to stream what it needs to know so the utility knows what's going on within an area of their networks.
Awesome. Thank you so much. I mean, I think you guys have touched on this a little bit, but Revelo provides benefits to both utilities and their customers. But can you go into a little bit more detail about what those benefits are?
Yeah, and we're talking about benefits for consumers, benefits for utilities. There's some that are obviously at the intersection where the utility is benefiting by having engaged consumers who are doing a better job of managing their energy, better ability to hook into the programs utilities might care about, whether those are efficiency programs, demand response programs, or even linking into things like electrification programs. By having this intelligence at the edge and engagement with consumers, we can be working with the consumers in ways that benefit the utility. So there's an intersection there is super important, and and that does also benefit directly consumers. And as Tim's talking about, there's some very direct benefits to utility on the grid side to know what's happening in the grid. But it is that combination. I mean, take things like as more and more people are getting EVs in their homes, what is that going to do to the strain on the grid? If you can start to have automation where the consumer doesn't care when their car gets charged, that they trust an application to say, I'm going to plug in my car, I just want it to go far enough tomorrow, you decide when to charge it. that's going to have big, big implications in terms of what you got to do throughout the entire network to support this kind of increasing big dynamic load, combined with all the renewables we have on the other side.
And Joyce, I would add to that just a general observation that let's not, we're talking about wave 2 versus wave 1. Wave 1 sort of built a technology layer to meet a certain set of requirements and didn't really think about what comes next as much as it should have. Wave 2, we really think we need to future-proof for the future so that the infrastructure is not locked into any old paradigms. There's flexibility and future-proofing. So we've tried to build a platform for things we're not aware of that's coming next. So how do we, the consideration are things like, how do we separate a core metrology function that's a utilities cash register that we don't want to put at risk, but allow the ability to create a lot of space for data manipulation at the edge of the grid, inside the meter, for power quality applications, for orchestration and balancing of DERs, for doing things that are available today, but not knowing what we're going to have to do tomorrow. So that's why we believe signatures are important, and we've gone beyond just simply needing load profile data to give the right amount of data to the utility. It means creating a safe, secure platform that a partner like Mike can operate inside and extract value on and still not put the utility at risk of its core business. So future-proofing is an important consideration.
Most definitely it is. So what makes this different than anything else that's available on the market today?
So a couple things. The sample rate is definitely the biggest thing. Getting to the point where Mike can see waveform characteristics is the big change. Not just measuring in increments of 1 minute or 15 minutes, but actually having the signature of the sine wave disruptions when things happen at the edge. That's one. Creating the platform to do the edge computing. So creating a platform like today, people can create applications to serve you in your iPhone or your portable or your Android phone, whatever your personal device is. How do we bring some level of that to bring more of the ecosystem to bear to help utilities solve problems like Mike is? So I think that is to create a platform that's also a bit different. We don't want it to be tied into the core metrology, what I was saying a minute ago, that we want to create a safe platform that isolates the data and then allows the utility to have control. Because while I'm comparing it to iPhones, utility meters need to be controlled by a utility. How these systems work and the IoT systems that they're investing in, we need to build in the control so that platform can be exploited and manipulated, but done in a safe way that they control. So I think that's the two big differences, is creating, the right level of edge platform. There's a lot of decisions to be made there, not just computing power, but how do you structure the architecture for that safety? And second, back to just the amount of data we're able to collect locally and compute on locally. So the waveform.
Yeah, and look, there is a lot of discussion about edge computing and so on, but Sense as an application probably pushes the boundaries of what needs to be on a meter compared to most other applications. But I can say that the Revelo meter is the only one that has enough capabilities to run Sense. So we're super excited about this partnership. And let me just put one more bottom line about how is this different than everything else. This really is the first time that we made it so that utilities can provide to all their consumers this real-time energy related experience. I mean, the real-time part, I know I keep coming back to it, but we do know that providing a real-time energy experience is absolutely key for a lot of the benefits that utilities want and how you engage consumers. And this is the first platform on which this is possible.
Awesome. Thank you so much. We did have a question come in from the audience. What publication can I read to see what apps you have in mind? And are these apps evaluated in terms of payoff? Like, are they practical apps?
Great question. And you're going to catch me off guard in exactly telling you where to go find it. But we have on our website, when you go to the Revelo product, you can find the examples of what we have out of the box in the meter. And it maybe not the spec level you need, but I believe if you ask for it, we can get back to you and connect you with the right data. But the question on what are the apps and are they useful things to begin with? We've built some foundational things in the meter to allow our partners to leverage some of that functionality and not have to start from the beginning. So, we talk about managing voltage in the meter and providing it to the cloud for use, or providing it locally. There's some apps in the meter now that allow you to intelligently filter out the voltage levels that are important for you to notice, and pattern detection that allows you to do things like fault detection. Those are the types of things that'll be in the meter out of the box on the grid side. On the consumer side, some basic load disaggregation. We are not going to be out there doing Mike's service that really you need a customer to fully buy into and opt into. But if you want some ability to provide your customers some basic information about their usage, it'll be sitting in the meter that you can also make available for someone to opt in, or just some basics about how do you support the consumer better.
Great, thank you so much. To kind of go back to some of the data questions or the data aspects, right? What would you say to other people who are saying that the level of data that you're capturing is not necessary or it's overkill?
Yeah, we've been deep into this. How do you give this real time, as I keep coming back to, detailed view of what's happening in the home? You can only do this with this high resolution waveform data. If you have even something like 1 second interval data, you can come up with some historical estimates of how much of your energy went into different broad categories. But even take a big thing, like we've used this example of a oven versus an electric dryer. You cannot tell the difference until you get down to the higher resolution waveform level between those things. And if you don't have that, you have to go back to the historical notion of how much of your energy went into one category or the other. Whereas if you want, from a consumer perspective, my dryer just turned on right now, or more relevantly, my oven is on when I left the house for the day, or my dryer is done, so I know to go down to the basement and take the clothes out. You cannot do that. It just defies the laws of physics. You cannot do that unless you have this high resolution waveform data.
Yeah, I would add to Mike's comments that first, it's not a big technology leap we're making first. What Landis+Gyr did was it took the metering engine out of our elite grid meter, which the elite meter was an expensive meter you put in a substation or an industrial site. It had a lot of cost and pretty heavy architecture in the meter, but the digitalization of creating the waveform is not a hard technology to translate or an expensive one. So that was translating that technology into our core residential meter. Pretty easy decision, whether you use it or not. The ability to have the waveform accessible is in every meter. Just, it seems like a baseline for the future for us. And the second thing I'd say is that when people ask what from the utility world, and I put my distribution hat back on, and they say, what's the one thing that makes this pay off? The one thing that gets their attention is when I say, I can tell you when there's outages right now, but in the future, just like Mike can predict what's going on inside of an appliance in a home, you pair that capability with peer-to-peer abilities with meters around it, and I'm going to start to tell you with high probability what caused a fault, what caused the power to go out, and where it happened. So instead of just going out and trying to find out why you had a fault, you're going to have data that says there's a very strong chance you had this type of anomaly, and you're going to know how to equip your crew without even rolling a truck out there to investigate, to fix the problem. So the value of that, you can't do it in real time without this level of data.
Thank you. You guys mentioned that there are several new projects that are on the horizon. Will some of them include Ravello?
Yes, we have interest from anybody talking to us about their next rollout, whether it's a targeted set of bellwether meters or full deployments. everybody's looking at this, and especially things like that last use case I put out. It's just, that last use case is basically building a much, much more robust event capability out of the meter than we ever had in the past. Out of the box, you have more intelligence about what's going on at the edge. The payback on that is pretty easy to create.
Yeah, I mean, it's certainly our view that for anyone considering new meter rollouts, given that what Tim is talking about here is now possible, it would be really a shame to roll out new meters of an older style meter that doesn't support this. And it's the high resolution data, edge computing, and most importantly, I think this future proofing by having ability to update and add applications over time. It's going to be hard to predict what we're going to need 10, 15 years from now. And having a future-proof platform is so key. And this is where I got back to my point that Sense pushes these meters way more than any other applications. I'm pretty sure if a meter can run Sense, it can run pretty much anything you might come up with. And so I view us as kind of the leading edge of what is needed and what's possible. And right now that's on the Revelo meter.
Great, thank you so much. And I've just got one more question for you guys. How does the greater edge intelligence and computing impact the utility of the future?
Makes them more responsive, provide more products to their customers, lights stay on, or lights get fixed quicker. So the lights stay on more. I mean, generally it makes their life easier from an operational side of the business, and it allows them to bring on DER penetration. At some point, we have the technology to help manage that disruption at the edge.
Yeah, we at Sense are very focused on this energy transition of more renewables, more focus on carbon, and more things like electrification. And we're just convinced that having intelligence in the home, and the meter is the platform that utilities can influence. It's kind of this platform at the intersection of energy on one side, smart home on the other. It's just a key place to be in the home to drive this intelligence that results in all the things we care about in the energy transition.
Fabulous. Well, gentlemen, thank you so much for your time today. It was really informative.
Thanks for having us.
Thanks to us. Yep.
Yeah. Up next, we've got a panel with a whole bunch of really wonderful individuals. They're going to be talking about all things related to the, oh my goodness, business agility. And I believe that's going to be hosted by Dylan Lockwood. So stay tuned.